Good morning. My name is Mrs. Douglas, and I am responsible for mathematics at Homer Green Senior School. My department consists of 9 members of staff who love their maths. When you join us in Homer Green, you will be developing your algebra, shape and space, measures, and data handling far deeper than you could ever imagine. I am delighted to introduce to you my 6th form, who will show you how a simple concept like area develops as you go from year to year during your time in Homer Green Senior School. So Amelia, do you think you can work out the total area of that shape?
Yep, so the general formula for finding the area of a rectangle is length times width. So we've split our larger triangle into larger rectangle into smaller rectangles. So for each side, it would be 5 times 5, 25. For the next one, that would be 10. These are all meters squared. For this one, it would be 30 meters squared, and for the last one, it's 12 meters squared. So to find the total, we have to plus all of these together in using column addition, and that's going to give us 77 meters squared.
So let's imagine that paint costs £2.40 to cover a metre squared. How would we then work out the cost of the paint?
So we know the total area is 77 metres squared. So we multiply that by £2.40, which is going to give us 184.
So is there a quicker way of doing this, do you think?
Yeah, so instead of working out the area of each of the smaller rectangles, you can work out the area as a whole by adding up the sides to work out the sides of each of the larger rectangle. So 5 plus 6 would be the top length, which is 11, and then 5 plus 2, which would give you 7, and if you times those together, that also gives you 77.
Okay, brilliant. So now we're going into year 8, Carla. So let's imagine that we don't know these two lengths. What do you think would happen in year 8? What do you think the students would face if they were working out area?
So we'd start to use algebra.
Wonderful.
So
show us.
If we know that these two sides are the same, we could make them both x. You could use sort of any number or symbol, like a question mark maybe, but we tend to use x in maths. So you then do the same there of working out the area in each, but now we're using letters rather than just numbers.
So what would be the area there?
The area there would be x times x, which gives you x squared. And then this one would be 6 times x, so 6x. Then 2 times x, so 2x. And then 2 times 6, which is 12.
So what is the overall area now?
So you'd add up all of the areas. So x squared plus 6x plus 2x plus 12, which gives you x squared plus 8x plus 12.
So from numbers, we're moving into expressions, algebraic expressions. So Archie, I want you to tell me what that actually looks like now. So what does x squared plus 8x plus 12 actually look like?
So we know it's quadratic because it has x squared at the front. And I'm going to put this into a graph. So I'll simply just draw a graph like this. However, we don't know the roots. So to find the roots, we make y, this is the y-axis, this is the x-axis. We make y equals 0, so we find the roots along the x-axis. So 0 equals x squared plus 8x plus 12. So then we factorise this to find the x's. So if we put that like that. For factorising, you have to make sure that these numbers times to make 12 and plus to make the 8 in front of the x, which perfectly fits plus 6 and plus 2, as 6 times 2 is 12, and 6 plus 2 is 8. So then you get this, and that equals 0. However, obviously, it's 0, so you divide both sides by x plus 2, so it'll be x plus 6, so 0 equals x plus 6, so x equals minus 6, and then do the same with the other one, so it'll be x plus 2 equals 0, so x equals minus 2. So we can sub this into our graph here, so we know that it crosses the x-axis at both these points, and then we know that this would look more like a smiley face because it is a positive in front of the quadratic x squared instead of a negative. If it was a negative, it would look like this. So then if I draw this onto here, it would look something like that. But then we need to know the y-intercept. However, if you make x 0 into this equation, 0 squared is 0, and anything times by 0 is also 0. So that would equal y equals 12. So it would be positive 12 there.
Superb, well done you. Okay, so now we've got a curve. Evie,
Yes.
what if I said to you, do you think you can find the minimum point?
Yes.
How would you do it?
So the minimum point is if you have a curve, it's the furthest down that x can be before, no, y can be before the graph doesn't work anymore. So with this particular curve, we can see with it visualized that between the ground with -6 and -2, we can see that the midpoint between that is -4. So with this, we can determine that the midpoint, the coordinates, x would be -4. Now we just need to find y. So with the equation x squared plus 8x plus 12, we substitute -4 in. So -4 squared would be 16. 8 times -4 would be -32. With a plus and a minus symbol, we go minus, so that'd be -32 plus 12, 16. There you go. And then that would be 28 minus 32, which would be 4. And then we have our coordinates, which is -4, -4. There you go. And that would be our
Superb,
minimum
well
point.
done you. And Amelia,
So
you're now in year 12.
yeah, a way we find the minimum points in sixth form is to differentiate our original equation. So I won't explain how to do that quite yet. But at the bottom of the graph, where the curve is eventually flat, we know the gradient is going to be 0 at the very bottom point. So we sub-0 into our differentiated equation, rearrange to find x is -4, sub the -4 back in the original equation, which will give us -4. So -4 is the minimum point.
Well done you. Amazing. So we offer GCSE mathematics to all our students. And when you get to year 11, you will choose between maths in context and A-level maths. So if you love algebra, you will follow the maths A-level side of things. And if you want to broaden your understanding of mathematics, you may choose to learn maths in context. A number of our students are entered into UKMT and they achieve very highly, achieving gold, silver and bronze awards in a UK-wide competition. We have in the past had a number of our students going off to red brick universities to read mathematics. Our results are in the top 13% of schools for progress in the country, achieving well above national averages for GCSE. And our A-level results are a flagship, often achieving in the top 6% in the country. We now have 50 keen mathematicians who study A-level maths in our sixth form.